Assalamualaikum. My name is Mohammad Abrar and I'm a student of A University doing mechatronics engineering from there. So for the course of micro, we have designed a line follower board with which has specific features. So from Sir Umar Farooq and Sir Zurgam, we were asked to make a board who follows the line using microcontroller 3280p and also have six sensors in it, and also displays the battery consumption, current and voltage readings, so how many current and voltage our motor is gaining. And also we have to store the path in the SD card. So for that purpose we have used two Arduinos because we are using a 3280p and we have limited number of pins for that. So for that purpose we have used two Arduinos. So that was our project which we were asked to be done. So we have done it all on both software and hardwareically. So we were two group members, me and Hussein. So we have used following components: chases, obviously for the board, and IR sensors, 6 IR sensors which are gonna detect whether our board is on the black line or not. Current sensor and voltage sensors to read the current and voltage readings respectively. And we have used two drivers, 298 and 293D. So for battery we have used 18650 batteries, 6 cells which provide one cell approximately provides 4.2 voltages of voltage on a full charge, and while on the 70% or 50% of the consumption is provide almost 3.7 voltages. So we have used 4 DC voltages. We have performed that on two different languages, one for the Arduino IDE and another for the C programming. So when we performed it on the Arduino IDE, we used 4 DC motors because our chases of 4 tires, and when we performed it on a C programming, we used 3 tires. So for that purpose, we have only 2 DC motors. So for ultrasonic sensors, for what was actually basic on all ultrasonic sensors, that there would be a header that there would be a header at the end of the path. If our board detects any header is will deviate that or take out 360 turns and move back in other directions. So for the LCD, so LCD is for the purpose that how much distance our board has covered, and how much current is consuming, and how much voltage is, and what is the battery status so far. So that was our LCD. And tachometer was basically to detect how much distance our board has covered. So moving to onward, I just have a quick review of what was our basic components. So our cell was rechargeable. So our current sensor's name has ACS712. Its accuracy is not that good for the current measuring, but very good at voltage measuring. So our LCD was of 16:2. So moving towards our block diagram. So before moving towards our explanation of a code or anything else, I would like to explain the block diagram. So there was a one Arduino was specified for the sensors, which line following you will say, and the other one is for the current sensors, voltage sensors, tachometers, and LCDs, and SD card module. So analog, we use analog pins as inputs for IR sensors, and ultrasonic is used as at the port. Ultrasonic has 2 pins, trigger 1 and echo 1. So both of the one were at D ports, and output was taken as from B, and C is the analog pin of our 3280p. So there was 4 outputs. So 2 were enables. So we control the speeds of the motor using enables. So PWM, which have we're gonna discuss later on, fast PW corrected phase. So for output 1 and 2, these are our motors, motor controllers, whether motor gonna move in clockwise direction or in anti-clockwise directions. So 2 motors left and right allocated for the motion of the board. So now moving towards the current sensors and the voltage sensors and tachometers. So voltage sensors also have a 1 pin which used as an input for the 3280p. They always give analog values. So our 3280p first converted the values in digital value, and then we get to display it on the LCD. So car module, basically we have 4 pins. Miso and Miso basically is the pins in which whether we're gonna read or write. If we're gonna read them, then we use Miso, and when we're gonna write something from Mose, the SD card module become master, and our 32AP become slave, and if or other else cases our 32AP become master and the SD card become slave. So that was a quick overview of our project block diagram. So now to move toward the mechanical design, so we prefer to use 4 wheel changes. So later on we move toward the 3 wheels in a C programming. So basically we design our program, we make our project using 2 languages. Number 1 for IDE, Arduino IDE, through Arduino IDE, and second one is C programming. So let's have a quick overview of our IR sensor. Basically we have IR sensor modules, so which give 5 volt value when it is subjected to any color other than black, because black is a great observant, is absorb any kind of infrared. So whenever it's subjected to the black line, it's give over 0. So this is the schematic of it. So this is our current sensor, which measures approximately up to 30 ampere we use, and voltage sensor which measures up to 25 voltage. So let's have a look on some specifications of our current sensor. It have a 18 kilohertz bandwidth frequencies. It can output sensitivity changes give output when if any change of 66 to 185 milliwatt per ampere occurs, it's gonna change its output. So basically it's taking voltages as a reference. We can see that a Hall effect sensor. So basically whenever voltage changes, the magnetic field changes, due to which current changes, current forces changes, which it take as a reference and measure the current. So low noise analog signals paths, and it has a 1.2 milliamp ohm internal conductor resistance. So it you can see that it's error of 1.5% at temperature, at room temperature 25 centigrade, which obviously we're gonna have. So stable output as offset voltage, we can basically offset the voltages, and near zero magnetic hysteresis, there's a hysteresis error in the magnetic field, which is a completely different field for us now. So ignoring that, we now moving toward the voltage sensors. So we can have basically 25 volt voltage sensor, which can measure up to 25 voltages, and 2 pins for its power VCC and ground, and 1 for the input versus coming in and what is coming out, which is gonna move in our 32AP. So its voltage, input voltage can be 0 to 25 voltages. Its voltage range, we have 25 maximum range, and a minimum is 0.02. So is a resolution is 0.04, which means frequency is up to 2 decimal places. So easy to use with the microcontroller, small, cheap, and easily available. Dimensions are also very small. So now moving toward our SD card module. So we have 6 pins, ground, VCC, basically we all know. Then Mito, Mozi, SCK, and C clock. So it can be used as a, it can use to read or write both for both purposes. It operates at 5 volts. So it's minimum. So you can say the operating voltage is 4.5 volt to 5.5 volt DC, and it can current requirements up to 200 milliamperes, and 3.3 volt on a voltage regulator, you can say. It supports up to 2 GB SD card and 32 GB SDHC. So that was our modules. And now moving toward the power issues, there you can see before moving toward the course, I want to explain every component. So before moving toward the code, we gonna know that has we made a board in DLD course, we know that power supply is main issue for anyone. So this time we have done a lot of research, and so we get to know that 18560 batteries are very good when they connected in series. They can give us 2 cell can give us amount of 9 volts. So we use 2 cell for that voltage control, and other one for the LCDs. So when they are fully charged, they can give 4.2 volts, and they have a long life. So probably a day was easily covered due to it. So that was our brief view of modules and the components. Now moving towards the code. So now I'm going to explain you about the code which I wrote it in IDE with the help of my partner Usain. And so first of all, I'm going to explain you about the line follower. Basically we have 2 codes, one for interfacing and one for the line follower, because we have using 2 Arduinos 32AP. So before moving towards C language, I would like to explain line follower board in IDE. So basically we A01, A1, A2, A3, A4, A5 are the 5 analog pins of IDE, 32AP. So we have declare A0 as 1, A1 as 2, A2 as A3 and 4, 5. So basically 1 is our the most right one, and the sixth one is the most left one. So we have 6 sensors in the front of our board. So for the motor, DC motors, we have 4 DC motors because I told you that we have right ID for the 4 motors. So right front, left back, and right back 4 wheels, 4 motors for the 4 wheels. So, and we have also control the speed because it was quite difficult for us to use PWM in ID. So we use had a speed. We declare a speed variable. So we deduce some amount of a speed from the our original, because we can in this library, motor driver library, we can set the motor speeds directly from our in IDE. So we have main functions. So we have declared that pin modes, whether our 1 2 3 4 5 are input or output. We have know that 1 2 3 4 5 6 pins, which are basically our sensors, are declared as input. So in while loop when we basically do a times. So our while loop. So first of all, if our digital read 1 mean is 1, it is detecting nothing. It is detecting nothing. It is detecting a white surface. If digital 1 2 3, everyone is 1, so it's gonna release. So release means stop in the Arduino IDE. So our motor gonna stop if everything is if none of black line is front of our board. So if there is a if digital not mean there is a not placed before, this mean if our every sensor is 0. So every we have a junction. So we have a junction. So you can say if we have a right one 1 and 2 have 1, so it's gonna run as straightforwardly. So we as we declared above that our right, left, front, back, center. So 1 2 3 are of center, most right, most left, and most left, and the other left on the center, between center and the most left one, and the right one is the most right, then the after that the right one, and then the center one. So if there's not is a black in front of if front two sensors are detecting the black, so our board will go straight. Or if our left right and left and right both our sensors are detecting something, it means we have to set a priority here. So we are taking right as a priority. So we are taking right as a priority. So if there's a black on the right, so we're gonna move toward the right. If we're gonna have a right and left both blacks, then we're gonna move toward the right. And we have some speed. We have minimize the speed just to control that if our board don't skid over the surface. So moving towards next. Again, if we have a right, if now we're going to move left. If we have a left sensors, our center ones are detecting the black line, and our left one are detecting the right line. So we're gonna move toward the left. So similarly, if our if any of our two sensors detect lines, so we have to, if this is for the curve, if our most left or most right one is detecting, then we have to move left to left. We have set the speed. We have the little offset for the speed, so our tire don't get straight on it. You know, if we want to move right, so then our inner move, then our outer tire should move with a more faster speed than the inner one, so it turns right. Exactly the same way, if our right ones are detecting lines, so it's gonna have to move right one. Then our then our right tires are moving toward the high speed, and our inner tires are moving with a low speed. So that's how our board gonna work. And exactly for that, we have a right priorities and left priorities, and how our things gonna work. If we want to move right, then then the left tires will move with a greater speed, and inner tires will move with less speed, so our board get turned right. If we want to turn left, then our left motor tires will run with a greater speed, and the inner one will with a lower speed, then so our board get turned right. So this is how our code was working. And we also have priorities. So if we got right or left, both sides are detecting line at the same time, then we will move toward the right. Or in the case if we have a straight left and right everything, so then we go straight. So that's how our board gonna work. So thank you very much. Now I will explain the next code of interfacing. So now I'm going to explain you about the interfacing code. So first of all, we included all the libraries of the module. So current sensor module, voltage sensor module library. Then afterward we have included the I2. We basically operated the LCD using I2C. So basically we operated a 4 LCD using 4 pins. So now we are included that. Then afterward SD card library included. First of all we make a file. So basically we're gonna be storing our SD card. So for a file we use as my file. So afterward I2C we explained that we have LCD to 16 class 2. Then we have float count, which basically count increases by incremented whenever at tachometer disk completes one rotation around it. So basically we measured that one tachometer disk measuring almost 9 cm after one whole rotation of it. So int variable and a float distance for a ultrasonic sensor. So basically our A0 pin is for our voltage sensor and current sensors, A0 and 1. And then moving towards the LCD, we initializes the LCD. And then afterwards we have backlight on, get our backlight on using a built-in function. Then we clear the LCD, whatever has been on the LCD get cleared. Now then we begin our SD cards. So if digital 6, so this is a tachometer. If digital 611, then we're gonna count 1. So triggered and distance will be count multiplied by 1.06. So this is basically our count cross 16 1.6. Whenever we have tachometer completed 1, then explain 1.06 units of distance, which is the IDE, and multiplied by count. So while loop, so it going on again and again. Now afterwards we have a current sensor. For a current sensor we have I. So what get current DC is the built-in function for the Arduino IDE. So whenever our current get whatever our value is getting coming, it will be stored in I, and we will be displaying it on the screen. So for our voltages, basically we are get this current voltage, so same. And for the battery we have to formulate a formula. So how many voltages our board is consuming will be, we have generated a formula for that. And whatever is coming in, and we multiply it by 100, so we get an exact value. So afterward we have make a SD file. So one tachometer is connected with that SD file, also storing our battery health and how many distance is covering, and it's displaying it on the LCD, and our SD card done, and shows and whatever we are moving towards the distance will be stored in it, how many we move straight, and then we move right and left, whatever will store in it. So afterward my file, we have a SD card text file has been created in that. Afterward we have printed that battery plus voltages on the LCD and the distance on the LCD, battery health, and everything on the battery. As we are using I2 with the I2C, so we are operating LCD only 4 pins. So there was not that so for Proteus we can't make simulations of our interfacing because also in C programming we are operating the LCD with a 4 pins. So that's how our thing is working. And this you can see that current plus milliampere in milliampere, voltages in volt, and distance in centimeters as displayed on the LCD and also stored in the memory card. So mostly we have used the built-in functions. So we get the libraries of current modules and voltage modules and tachometer. That's why it was not that difficult in the Arduino IDE. So thank you. Now I'm moving towards the C programming. Now it's time to explain the C coding. So in a C code for a line following, so first of all we included the AVR library as administrative library. Then we have delay library, so and define our frequency of our 328p. So we have two function speed and speed A for the PWM usage to control the speed of the motor, and then we have a 4 functions stop, forward, right, left for our motor. So for our turns, so whether our motor gonna rotate in such way that our motors that our board stops, or will move in forward direction, or will turn right, or will turn left. So we have a sensor 0. So this is our sensor. We have defined our global variable. Now move to for the C function. This is our input, as I explained you. The analog pin are we using, and analog pin has an input for a sensor, and then B and D are the totally output for us. So we are taking sensors pin C. We are using whole port C as an input. So if we get, then basically this is our test cases. So instead of in the code, I would like it will be easier for me to explain you through test cases. Those cases we have tested. So these are the test cases. So we have basically six sensors. So most left, second left, first right, second left, or most right. If our none of our sensors detecting any, as it's on a black line, it will be stop. If most right is detecting one, it means more motor right will move, will rotate, and will our motor will turn, our board will turn in. It means that our one there is color on the right side, and we have to move left. So our right motor will rotate, and we will move left. And if secondly, if the second right on most right is detecting any color, then we obviously our board gonna move right, unless until our first left and first right get anything, and our board will move in straight direction. You can see. So forward direction. Now exactly in the same way, if our most left and most right are detecting something, if there's a color only most left side, then our left motor will rotate and our motor will go straight. So this is how our things work. And in the case whenever we have a zero or a straight in a center, you know, first and the second, first left and first right, then our motor will move in straightly one and one. You will see that. So zero means that our sensor is so one zero sensor detecting the line is on the black line, or one means that our board is on a black line. So I'm gonna explain you some functions using here from the demo. It means one on the most right mean there's nothing on the right side, all the black lines on the left one. So our motor so our right motor will rotate, and our board will move right. And similarly, these cases will repeat unless our sensors they start detecting middle ones or center ones sensors detect anything. So our board will go straight, or otherwise or if our right sensors are detecting black line, so our left motor will rotate, and our sensor and our board will turn right. So this is how our left right situation will work. So we have written 64 test cases. Obviously in a video I don't have such times that I'm gonna explain everyone, but majority I will explain you that if there's one, it means there's something colorful on our sensors were detecting, and on a zero mean we are on the black line. So for forward, you can see that everyone so from so else if any other functions comes, any other than these conditions come, then our board will go straight. If everything is black or everything is colorful, then our motor will stop. So this is how our things works. Or now now choose a random case and we'll talk about it. So let this is we have on the right side there is a white plane, and on the left side there is a black plane. So our right motor will rotate and move in towards it turn right, turn left. Right motor rotates, and our will left and right. So it doesn't mean that our left motor is gonna stop. It means that our left motor gonna rotate with a lesser speed than the right one. So for that we have used PWM. So we all know BMW. We have two pins of PWM, OCOA and OCB. So OCRA, whatever how many duty cycle forward to how many times of our duty cycle remains on, how many times of our motor will remain on. So speed act will be the that function. If for the 50% we have to give function value over there. So for COM 0A PWM we are using non-inverting fast PWM. Whenever our value get compared, it will get set. So we are using 0001 scalar. So this is our whole configuration we have seen in PWM. I'm gonna show you about that again from the lab reports. So serial communication, and next one is our ADC lab report 1. ADC, here is the ADC. So we have registers. So you can see that whenever our value get compared, it gets set, and we have duty cycle on off for that. So this is how our things working: phase selected, phase, and a compare mode. And we basically fast PNW is whenever it gets one, it's gonna get set and then on for that movement, and then again when it gets compared, it will get 0. That's how our thing has been working. So we have used PWM using that. So we have used that no pace killer, and then our two functions has been created. So basically we only call that basically we have first send one which you control the direction whether our motor will gonna move in forward direction or reverse direction. And also we have control the speed 107 for the power. We gonna have equal speed for the door both tires. For the right motor, our outer right motor will turn with the greater speed as compared to the inner one, and exactly the same way for the left turn, our left motor will gonna move with a greater speed than the right one. So this is how this code has been working. So thank you. Now I will move towards the interfacing. So now I'm going to explain you the interfacing code in a C programming. So we have first make our current and voltage sensor function and account for the count variable for our counting of a tachometer. So that ISR for the count. So we'll talk about that later. So we have first use pin D as something that output and something that input, and exactly for the DC first four C for first 4 pins are input and other 4 are output. So ADCSR 082. So for the conversion, we have started we have enabled the respective convergence variables stored. Now we have enabled our we are using external interrupts. So we basically first interrupt and with the no input level or so, and for input clock, and whenever a level get triggered, whenever level change, so our interrupt will be called. And for during interrupt 1, we are using interrupt 1, and SEI the global interrupt enabler. So initialize we are initializing our LCD. We are calling the function from the LCD H file. So we have created an LCD file for 4 pin for 4 pin mode communication. We are controlling our LCD using 4 pins only. So now we are moving toward, and we first initialize our LCD, and in a loop whatever created our versus plus battery health, then current, then distance, how many distance has been covered. So these are the functions. So basically we are concerned with the functions of how our voltage, how our board is taking the voltage, and our board is taking the current. So for the voltages, we are using the ADMAX channel 4. ADSR, we are first using ADSC, means that we are using start conversion. Then afterward the conversion will be there until our flag get 1. Our flag get 1, and conversion can completed. So after conversion completed, our whatever our voltages value will be. If it ADCH is equal to 1, then it means we have to get an offset of 256. Otherwise, these are the formulas for the conversion. If our ADCH is equal to, then we have to add 512. If our ADCH is 3, ADCL is 768. This is the standard, and whatever becomes, so whatever volt value comes will be converted into the digital 10-bit digital value and will be displayed at the output. So ADCH and ADCL will be, you may know that store value of the conversion. So for the current sensor is exactly the same way first we converting, and afterward if ADCH is equal to 1, we will add 256. If ADCH is equal to 2, gives 2 values, then we will have 12. If it gives the value of 3, then we add 768, and whatever value comes, we will convert it and display it on the will display it on the LCD. So for the count, we use an external interrupt. So whenever our ultrasonic sensor get anything, so it will count, or our disk rotates, and count will count parallelly, and how many distance cover will be displayed on the LCD. This is a simple code we have created in the C programming. So will be displayed on the conversion will be continue, and display the current whenever the current changes, and display the voltages whenever it's changed. So this is how our this is how our interfacing is going on. So thank you very much. So now we'll move toward the simulations. Now I'm going to explain you about the simulation. So basically this is our motor driver 298, and this is our 328P, and this is our we are using logic toggles as a infrared, because they are also giving 1 and 0. So these two enables are using an PWM, and these are 4 outputs for our motors. So now moving towards on, so let's simulate it. So we can see that, as we know that these are probably the most right one and these are most left one, as we know that we have to turn right, so our right motor is turning with a higher speed than the left one, so our motor will turn right. If I invert these things, if I gonna invert these things as our logic, you can see that now it have to turn right, as it have to run right, then left motor is rotating with a higher speed than the right one. And similarly, if I rotate these things again, now it have to turn left, then our right motor is turning with a greater speed than right one. So if it have to go straight, then it will for the straight, these will be the zero. Zero means the rating black line, and both the motor will run at equal speed. So you can see that both of the motor are running at the equal speed. If I changes that, if our motor have to move, now it have to move left, so our right motor is moving with the greater speed than our left one. Or now again changing it, and now we want to move on right. So if we want to move right, then our left motor is running with a greater speed than the right one. So this is how our thing is been working. So now after that we will move towards our PCB design. So as we use 4-bit model communication, we don't have any simulation for the LCD, it works on the hardware. So now moving towards the PCB itself, we have made schematic. So this is first Arduino, this is second Arduino, and these are connected for the rest of things. These are for the infrared sensors, these are for the LCDs, this is for the other things, tachometers, SD card modules, and these are things we placed. And we after that we have made our PCB design like that on 240 millimeter bone and 900 millimeter bone something. So this is our first Arduino, this is the second Arduino, and these are the connectors for the things. This is for the infrared, this is for the LCDs, this is for the voltage, this is for the current. So that's it. And how is gonna look in a 3D. This is how it's gonna look at 3D. So connectors we have seen. This is how it's gonna look at 3D. So PCB was a quite difficult because we have a limited area and we have to design the path on it. So it was quite hectic, and it took almost a day for hours to be complete. So that's how our PCB design has done. So now moving toward our how our practical things goes. So let's explain about it. Now I'm going to explain how we have done our practical work. So first of all, we have tested our whole thing on the Arduino. After creating our code on Arduino IDE, we have tested everything on the breadboard, and this is how we assemble our chassis. Now after breadboard testing, which is alhamdulillah was tested completely, and we also get it checked from the course teacher. So afterward we move toward the things, PCB board and printing. So first of all, we printed our PCB on A4, and then afterwards we have a copper board. So from there we have etched things we etched the from paper to on the copper board. Before etching, we have sandpaper. We perfectly smooth the surface of the copper board. After that, for the 30 to 40 minutes, we press the whole paper on the board, and after that we place that board in along with the paper on in the warm water, luke water you can say, and paper get dissolved in it, and we got our printed like that. After that we hide it we kept it in the FECL3 for sometimes for almost 45 minutes. After that we will get our PCB. After that we drill the bits, we drill the holes where necessarily to make a slot for the terminals, and after that we have soldered nicely, and you can see that how we get the result after etching. So after etching, we completely solder our board, and wherever wires were needed, we place the wires, and after that we this is how our board looking after completing the surface. Then we then we patch it on the chassis, and this is how our motors and look. You can see that how cleanly it was etched just because of FECL3. So and the final guy was, and this is how our board looks after placing Arduino IDs and microcontrollers on it, and motor controllers on it as well. So this was our 10 step journey for the practical design. First we tested on the breadboard. Then we shifted the toner on the copper board, and then we drilled the inlet. Then we placed the drill in it. Then we edged, and then we soldered, and this is how our PC board was seen. Then we placed the component on it and checked in our board was working properly. So I would like to show you some video of it before ending the video. That's how it's been working. So this is our board properly working on. This is our interfacing. You can see that interfacing on the LCD displayed everything. This is soldering, and this is our LCD displaying everything. And afterward, this is how our board been running on the black line. So sorry, video got cut. So that's how our board is properly following the line. So now I will show you some of our working. Thank you very much. It was great working on this project, and I am thankful to Sir Umar Farooq and Sir Zagam for providing us such platform that we can enhance our practical skills. Thank you very much. Take care. Allah Hafiz.